So today we shall discuss the next laboratory experiment with regard to movie database. So the different tables in this movie database include actor, director, movies, movie cast, and rating, and the various attributes. So in these tables are specified. So actor include actor ID, name of the actor, gender, then director, director ID, name of the director and director phone number. Movies include movie ID, title of the movie, year, language and the director ID. Movie cast include actor ID, movie ID and the role. Rating include movie ID and the review stars. So these are the five tables along with the various attributes. So now let us look at the various queries we need to run on this particular movie database. List the titles of all movies directed by Hitchcock. Find the movie names where one or more actors acted in two or more movies. List all actors who acted in a movie before 2000 and also in a movie after 2015. Use join operation. So find the title of movies and the number of stars for each movie that has at least one rating and find the highest number of stars that movie received. Sort the result based on movie title. Update rating of all movies directed by Stephen Spielberg to 5. So these are the 5 queries which we need to run on this particular database. So in the question here itself, the primary keys will be marked. So here in this PDF that underlining is missed. So we shall directly go to the entity relationship diagram. So before that, just have a glance. Actor, actor ID, director, director ID, movies, movie ID. But along with that, movies and the director are linked using the dir ID field that is present in the movies database. And in the movie cast, actor and movies are linked. So which means actor, movie, movies are linked through movie cast where actor ID, movie ID, role is present. And the rating for each movie is stored in the rating table. So based on this, let us look at the entity relationship diagram. So actor, movies, director are the uh, strong entities. So for actor, we will have actor ID, actor name, gender. So he will participate in the movie cast. So movie cast is the relationship between the actor and the movies. So the additional attribute that is present in the movie cast is the role. So the other two attributes include the actor ID and the movie ID. So in movies relation, movie ID is the primary key, title, year, language and stars. So stars is specified as a weak attribute. So that double arrow indicates it's a. So this review stars, uh, if we can look over here, the rating table. It is just movie ID and stars. So which means this entry solely depends on movie ID. So that's why, so that review stars is written inside this particular double ellipse. So director table, so director ID, name, phone number, and the director and the movie is related because in the movies itself we have a dir ID. So now let us look at the schema diagram. So the arrow marks indicate so which is the foreign key that an attribute is referring to. So in actor table there are no foreign keys, only actor ID is the primary key. In director table, so director ID is the primary key, no foreign keys are present. In movie table, movie ID is the primary key, director ID is the foreign key referring to the director ID of the director table. In movie cast table, so actor ID, movie ID together they form the primary key, whereas actor ID is referring to actor table, movie ID is referring to movie table. Then rating, so it is referring to movies table, and stars is an another attribute. So based on the arrow marks and the uh, underline for the primary key attributes, so we have to create the tables. So let us create the tables one by one. So the commands for table creation. So create table, actor, actor ID. It is a number. So we are declaring it as a 3-digit number. And it is the primary key. Actor name, varchar of 20. Actor gender, it is a character 1. So character 1 means, so we will be indicating the gender using a single character M or F. So once we create this particular table and run it, so we can describe it in the Oracle. So describe actor. So then I have already executed and added a screenshot of the description of the actor table. So the columns will be actor ID, actor name, actor gender. So the primary key, here you have 1, so which indicates the actor ID is the primary key. So which means actor ID should not repeat. Number, so precision is 3. Name is a varchar of 20 and gender is character 1. So the first table actor is created. So and it doesn't include any foreign keys. So then the director table. So create table director, director ID, number, primary key, then director name, varchar, director phone number. It is a number of 10 digits. And again here the primary key is number and no foreign keys are present. So when we execute this creation table command, and then we have to issue the description command. So DESC director, then the table will be described. So next table is the movies table. Create table movies, movie ID, number, primary key. Again, this number you can generalize it in all the tables to 3 or 4. So whatever value we can specify over here. Movie title, varchar, movie year, number, movie language, varchar, director ID. Here we are not writing the data type. Instead, we are directly referring it to the director table. So DIRRD references director of director ID. So you can observe the attribute name in both the tables is same. So if it is different, we will write a different over here. So in the director table also the attribute name is dir ID only. So then if we describe the movies table using this particular command, so we'll get this particular description of movies table. So movies, movie ID, title, year, language and dir ID, and the primary key is the movie ID. So next table is the movie cast table. So why a separate movie cast table has been created here is because in one movie there will be many number of actors. So we cannot store, it becomes a multi-valued attribute. So that's why a separate table is created to store the all the actors details who have participated in that particular movie or acted in that particular movie. So movie cast, actor ID, number, movie ID, it's a number, role, it is a varchar, primary key. So here in this particular table, so these two attributes together they form the primary key. So that is the actor ID and the movie ID. So primary key of actor ID comma movie ID. So foreign key actor ID references actor of actor ID, and foreign key movie ID references movies of movie ID. So instead of declaring these two attributes, so we can directly we could have directly added them as a references just like previous examples, but this is an alternate way of specifying a foreign key. So here instead of writing it as number of 3, so we could have directly written references actor of actor id. So just like we have done in this particular table, so director references director t. So this is one way of referring it. So the alternate way is just we can define it like this. And one more alternate way is, while declaring it, we can give a name to this foreign key also, so that we can easily drop it if not required. So you can observe the primary key 1 and 2, it indicates both these attributes together they form the primary key. The last table, the rating table, create table rating, movie ID, number, primary key, review stars, varchar of 25, foreign key, movie ID, references, movies of movie ID. So here this movie ID is both the foreign key as well as the primary key in that particular table also. So with this, the creation of all the 5 tables is done. Then we have to insert the data. So inserting the data is done using the insert command, but while inserting we have to take care of the queries that has been asked in this particular experiment. So first thing is uh, list all the movies directed by Hitchcock, which means we should compulsorily add a director with this particular name. So otherwise when we execute that particular query we won't get any result. So one of the directors should be this person. So next, at least 2 actors should be acted in 2 or more movies. So we have to enter the data such that, so we have an actor who has acted in more than one movie, and list all the actors who have acted a movie before 2000 and also after 2015, which means we should add a movies before 2000 and after 2015, and some are the other actors should have acted in a movie before 2000 and also should have acted in a movie after 2000, so 2015. So like this we have to enter the data, otherwise we won't get a result. So find the title of movies and number of stars for each movie that has at least one rating. So for this particular query there is no restriction on the data. The last one, update rating of all the movies directed by Steven Spielberg. So this is again another director. So we have to add one more director with this particular name. So one is the Hitchcock, another one is Steven Spielberg. So these two should be compulsorily there in our data. So then all other details we can enter as per our wish. So let us look at the first query. List the title of all movies directed by Hitchcock. So title of a movie is present in the movie table and he is the director, name of the director. And in order to link the director and movies table, so we have to use the dir id. So what we need, so in the question it is asked only title. So what we'll write over here, select movie title. So from movies M, director D. So M and D are the aliases now, where M dot dir id is equal to D dot dir id. So which means both the tables are joined based on the director ID. Then we have to put another selection condition, that is D dot dir name. So that is the name of the director should be Hitchcock. So that name we have to specify. And the attribute which we select is movie title. So here if you observe, we have not added the alias for this particular attribute, because this movie title attribute is present only in the movies table and it is not present in the director table. So if any attribute is involved in both the tables, then presiding it with an alias is compulsory. Otherwise, it will raise a error that there is an ambiguity in identifying the table to which this attribute belong. But here there is no such thing. So only this movie title is added. So before that, let us have a look at the data that we have entered. So for actor table, so we have used the actor ID 1234, then the actor name like this, and the gender. So anyway, we can enter any values because there is no restriction on actor in any of our queries. So actor ID we are using 1234. Then director values 11, 12, 13, 14, and name of the director, and two directors should be present in our database. That is, one is the Hitchcock, another one is Stephen Spielberg. So and director phone number, any 10 digits we can enter. So director ID is 11, 12, 13, 14. So four directors are there. So then movies. So we have added a movie ID 21, 22, 23, 24 with some movie titles. So these things, year, movie year 2019, 15, 99, 2016. So we need at least one movie before 2000. So I have added this 99. So even though all of them are in 2019-20, so for query purpose, we can enter any values. Then movie language, then the director ID. So director ID is 11, 12, 13, 14. So we have to use only these four values. We cannot use any other value because we in our table only 11, 12, 13, 14 director IDs are present. So only these four values should be used over here. So for example, here movie ID 21 Diya. So director is 11. So director 11 is Raju. So Raju is the director of first movie. So then 12 special ops. So it is Hitchcock. So Hitchcock is the director of special ops. So like that, breathe 13. So it's Manju. Then Money Heist. So it is Stephen Spielberg. So like that, when we join based on the director ID, so they get added as a separate column in the result. So movie cast. So movie cast means actor ID, movie ID, what is the role? So actor 1 in a movie 21 lead role. Actor 2 movie 21 support role. Actor 3 movie 22 guest role. 4 23 lead role, negative role, guest role. So like that we can enter the actor in which movie and what role they played, whether it is a lead role, support role, guest role, or negative role, like that. So then rating, so followed by movie IDs 20 to 24 is the movie IDs. Rating we can specify any values. So 4, 2, 5, 4 has been entered. So now let us look at the result of this particular first query. So that is movie title where the director is Hitchcock. So such Hitchcock is directed, has directed the movie title Special Ops. So let us again cross verify this. So first let us go to Hitchcock. His director ID is 12. So you can observe over here. So Hitchcock director ID is 12. Now let us go to movies table and find where director ID 12 is present. So movie table. So director 12. So it's yeah, movie title is this Special Ops. So this Special Ops we need to print. So if he has directed more than one movie, then all the titles will be displayed. So Special Ops is our result. Then the second query. So we shall look. Find the movie names where one or more actors acted in two or more movies. So here there are two conditions. So first thing is, in a movie there should be more than one actor. First case. Second case is, so whoever actors are there, they should have acted in more than 2 movies. So that is a condition. So both way, a movie should have more than one actor. So let us assume some movie is having more than one actor. So maybe 5 actors. Now what happens? Out of this 5, we have to identify those who have acted in more than 2 movies. So that list we must display. Again, only movie name is asked here. For this purpose, we have to have a inner query. So first what we do is, so we will extract the actor details, so who have acted in more than 2 movies, or who have acted in 2 or more movies. So the innermost, let us start with the innermost one. So this part, select actor ID from movie cast, group by actor ID, having count greater than 1. So which means in the movie cast table, we'll group it based on the actor ID. Then for each group, we'll check how many rows are there using count star. So if we are applying any condition on a group itself, we have to use the having clause. So count of star greater than 1, it indicates the group that is having more than one row that will be selected. So that group, we are only selecting the actor ID. So now what happens? This inner query will select all the actor IDs that have acted in more than one movie. So count of star greater than 1. Okay. So here now when we run this particular query, this part will be replaced by a list of actor IDs who have acted in more than one movie. Now let us go back to the outer query. So in the outer query, so in the question only movie title is asked. So we'll put select movie title from movies M, and in the movie table we don't have actor ID. So the only way to link the movie and the actor is through the table movie cast. So we will be selecting the movie cast table with an alias MV. So we'll link movie and movie cast using, so m.movie id is equal to mv.movie id and actor id. So actor id is the attribute that is present in the movie cast. So this actor id should be present in this particular set. So this is the condition over here. So first let us identify the actors who have acted in more than one movie. So that we can identify by looking at the data that is present in the movie cast table. So let us go back to in the movie cast table. So here you can observe that observe that the actors that have acted in more than one is 3 is present over here, 4 and 4. So the actors who have acted in more than one movie is only actor 3 and 4. Okay. So now what happens when we run this particular query, this entire thing here, whatever this particular query is replaced with that value, that is 3 comma 4. So this thing will appear inside the parenthesis. Now our query will be actor ID in 3 comma 4. Group by movie title having count greater than 1. So this will give a two-way result, that is here also the actor should have acted in two or more movies, and here also this ensures that whatever movie that we select, so that has more than two actors. So two more, that is greater than or equal to two actors in a movie, and here so that is two or more movies, so acted in two or more movies by a actor. So this is if you observe, there is no relationship between the outer query and the inner query. So all the attributes whatever we have used belong to this particular movie cast table only. So this is just a nested query and there is no correlation. So such movie is breathe. So again let us cross verify it. So only actors 3 and 4 have acted in uh, more than two movies. So now let us go back and check the movies in which there are more than one actor. So if you observe here, so let us write select movies so in which there are more than one actor. So that includes movie ID 21. Yeah, let us write it over here, 21, then 23. So these are the two movies there are in which there are more than one actors, and similarly on the other side the actors, more than one actors are 3 and 4. So actors ID is 3 and 4. Now let us check whether these 3 and 4 acted in these two movies or not. And here we need to print the movie name. So if you observe here, actor 3 has acted in which movies? So actor 3 has acted in 22, 23, and actor 4 has acted in again 23 and 24. Okay, so actor 3 has acted in 22 and 23, whereas actor 4 has acted in 23 and 24. So we can observe here. So here, here, and this. Okay. So now this is with regard to actors. So on the movies side, these are the two movies in which there are more than two actors, right? So now 21 movie has two actors, but 21 movie actors are 1 and 2, but 1 and 2 have acted only in one movie. So this fails to meet the actors condition, right? So the only remaining is 23. Now let us see whether 23 is having any actors. Yes. So 23 is having a actor who has acted in more than two movies. So this movie 23 satisfies both the conditions. So that is it has two actors, and the actor who has acted in the movie 23 has acted in more than two movies. So our result should be movie 23. So which is that movie 23? So let us see. So 23 is the breathe. So you can observe. So when we execute that particular query, so we should get the result breathe. So yeah, here is the screenshot of that particular result. So movie title is breathe. So next, let us look at the next query. List all actors who have acted in a movie before 2000 and also in a movie after 2015. So here what is asked is we have to use a join operation. So that is first part. And here, so a person should have acted in a movie before 2000 and also should have acted in a movie after 2015. So first we'll uh, see how to identify those who have acted before 2000. Then we will identify those who have acted after 2015. Then we will find the intersection of that. So that will give us the um, result of actors who have acted before 2000 and also after 2015. So with this table only, we shall write the year. So year also we shall mention so that so movie ID 21, its year is 2019. So let us write over here. Yeah. So let us assume we are joining this particular table with the movie title, movie table. So just let us write the year also over here. Okay. So movie 21. So let us find out which year it is. So movie 21 is so movie 21. It is in the year so 2019, and here also 21. So it is 2019 only. So movie 22. It is in 2015. So that is what the data we inserted. Then movie 23 is 99, and here also it is 99. Then movie 24, it is 2016. Okay. So in our question, what is being asked is we must identify the actor who have acted before 2000 and also after 2015. So for each actor, so we'll write the actor and check whether he has acted before 2000 and after 2015. So this we will write. So for each actor. Yes. So first let us take the actor ID 1. So actor ID 1, so he has acted in movie 21, that is 2019. So 2019 means has he acted before 2000? No. And has he acted after 2015? Yes. So cross mark. Now let us take the second actor. So second actor. So it is 2019 only and nowhere else he is present. So before 2000 into mark, after 2015, yes. Next, actor 3. So he has acted in 2 movies. So first movie is here, it is in 2015. So we need after 2015. So we will not consider 2015. So we will not write that. And here it is one more time it is present, it is 99. So 99 means it is before 2000. Here we will write. So before 2000 means we will consider only till 1999, and after 2000 means we will consider only 2016. So both inclusive of 2000 and 2015 we will not consider. Then fourth actor. So fourth actor is in 23. So 23 is 99. So tick mark. Then another 4, it is 2016, another tick mark. Now, according to our query, so we need only those actor who acted before 2000 and after 2015. So both side it should be tick mark. So here first one we cannot select because he has not acted before 2000. Second one also he has not acted before 2000. Third one he has not acted after 2015. But the fourth one has acted before 2000 also and after 2015. So this is how the queries get processed when we join the tables and put the conditions, right? Then so actually what happens, so we just manually looked at it, but as a set operation, so what happens is if I may I have to mention it as a set, so it is 3 comma 4, and this one will be a set operation as 1 comma 2 comma 4. So first set, so this is before 2000, and this one is after 2015. Now the actual result will be intersection of these two. So when we perform the uh, intersection operation, so the result we get is 4. So because 4 is present in both the sets. So who is the actor 4? For that we have to visit the actor table and find it out. So the actor 4 is the Umesh. So when we execute this query, so Umesh should be printed. Now let us look at the query. So in the query, it has two parts, that is before 2000, after 2015. So in the first part, what we have to do is, so we have to join the actor table and the movie cast table. So actor table, but here in a question, there is one more thing that is asked, that is we have to use the join operator. So even though we join the tables using where class, we can also join them using a join keyword in the for itself. So here it is the first join we are performing, actor A join movie cast. So which means these two tables are joined, actor A and movie cast C, on which attribute? On actor A dot actor ID will be equal to C dot actor ID. So this part. So this is similar to writing a table and having the join with a where clause. So instead of putting the equality in the where clause, so we can write it in the from itself. So using the join operation. So table 1 join table 2 on condition. Then this entire part is now joined with this part is 1 with join movies m on c dot movie id is equal to m dot movie id. So which means we are joining A C and M, that is the actor, cast and movie based on the conditions. So first we will join these two tables, then we will join the result of this with this particular one. So the required result is join will be obtained over here. For this we will put a condition, that is movie year should be less than 2000. So since in the question it is asked it should be before, so we have to use less than. So similarly, on the other side, so we have to add the condition, that is movie year greater than 2015. The only change is this one. The rest of the things until here it is same. So only is greater than 2015. There in the previous case it is, you can observe here itself, less than 2000. Now this part of one query, another part is another query, both should be joined with intersect operation. So intersect, it is a keyword to perform the intersection operation. So now our result will be actor Umesh. So when you execute this particular query, you can individually first run this particular part and check the temporary result. We should get the actors 3 and 4, and then you run this particular part separately and you verify, you get the correct number of actors. Then you add a intersect in between and run the entire query, you will get the result. So the next query, find the title of a movie, number of stars for each movie that has at least one rating, and find the highest number of stars that a movie received. Sort the result by a movie title. So this question is basically on the ratings, and this question has been designed such that with the assumption that each movie will have a different rating given by a different user. But in the schema it is specified that a movie ID is a primary key, which means for each movie there will be at maximum only one rating. So that itself becomes the maximum stars. So what we do is, so we need movie title and the maximum stars it has received. So movie title is present in the movie table, whereas the rating is present in the rating table. So these two can be joined using movie ID. So m dot movie ID is equal to r dot movie ID. So where r is alias for rating table and movie table, m is the alias. So for each one of them, so we will group based on the movie title. So then number of maximum stars should be greater than 0. So which means it has at least one rating. Then we will order the result based on movie title. So the last part in the query is sort the result based on movie title. So the movie should have at least one rating. So 1 means it should be greater than 0. So that particular condition is also added here. So then based on the movie title, it gets sorted in the alphabetical order. So along with the stars it has received 5, 4, 4, 2. So in this query, we can remove this having clause also. So while executing this, so you just remove this having clause and verify So what change will be there in the result? So there will not be any change even if we remove this particular having clause. So the last query. So update rating of all movies directed by Steven Spielberg to 5. So here the movie which is directed by Steven Spielberg, its rating we have to change it to 5. So in order to change it, so we must identify all the movies that are directed by this particular person. So in order to do that, first we have to go to the director table, get his director ID, then go to movies table, get the movie ID, then go to rating table. For that particular movie ID, change the rating to 5. So the query will be like this: update rating, because the rating is present in the rating table. Update rating, set review stars, received stars is equal to 5. So because this is the attribute, so we are setting it to 5. For whom? Where movie ID is present inside this. So this particular part of the query will find the movie IDs directed by this particular Steven Spielberg. So how to find it? Select movie ID from movies and director. So link the movie ID and the director using m dot director ID is equal to d dot director ID, and d dot director name is equal to Steven Spielberg. So the name whatever we specify inside this single quote should be exactly the same which we have used in the insert statement. So the same you have to specify here. Then what happens? So in place of this entire query, the movie ID, all, if he has directed 10 movies, all the 10 movie IDs will be present inside this parenthesis. So if you have directed 0 movies, then there will be no entries. Or if he has directed only one movie, then one movie ID will be present. So all the movies he has directed will now have an updated rating 5. So this is the once this command is executed, so uh, the rating will be updated. So in order to verify it, so we have to check the rating table data. So in order to check the rating table data, so we have to specify this particular command, that is select star from rating. So now we can observe over here. So first, before that, we have to identify which is the movie directed by him. So the movie directed by him will be presented in um, movies table. So first Steven Spielberg, so you can identify his director ID is 14. So 14 movie is here. So 14 means it is Money Heist. Its ID is 24. For the movie 24, what is the rating? Let us check. So Steven Spielberg, his director ID is 14. So 14, he has directed the movie 24. For 24, what is the rating? So we have to check it in rating table. For 24, the rating is 4. Earlier it is 4. Now when we run this update command, so for 24, you can observe here, so it has been updated to 5. So these are the 5 queries. So execute this particular experiment by creating a table, check their description, insert the data into the table, then check the table data, and then execute these 5 queries and verify its result. Okay, so we can stop here. So within the next laboratory session, so within a week, you complete the execution of this particular experiment.